Hey there, lovely people. This is Z-Wink, and welcome back to Z-Wink University. I ran a survey on Twitter the other day, and people, it looks like by popular demand, want to see authentication bypass. An authentication bypass, what is that? Well, in the bug bounty hunting world, it is a P1 or a critical most of the time, and it is essentially a way to get past a login dialog. It's a way to get to somewhere or access something that's meant to be behind authentication. It can be as global as I completely found a way to bypass all authentication with a tricky little header value, or it can be as simple as I just sort of got to one endpoint that should have been secured but wasn't, but allows me to do a bunch of crazy stuff and things. And I want to talk about a bunch of different kinds of authentication bypasses, right? You definitely can't put this in a box. And my nose is itching. Wow. Let's go to bugcrowd.com. Okay, I want to play on Bugcrowd today, and we're going to actually use the Bugcrowd website itself to talk about authentication bypasses, kind of what you're looking for and how to maybe use some tools to help you find them. You can do it all by hand. You can do everything by hand, but auth bypasses are one of those things where I really do love an add-on once in a while. So let's get our proxy up and running here. I have already come over to the target and entered Bugcrowd in the scope, okay? So what we're gonna do now is go to bugcrowd.com, and I'm gonna log into an account. Researcher portal. And I'm gonna pause this and be right back. All right, and instantaneously I'm back and we're logged in. I didn't want to give away one of my email addresses in a video, so all I did was type in a username and password, and we're logged into Bugcrowd now. All right, so what we've done is logged into a system that shows you more stuff once you're authenticated, right? You're logged in, now you see more stuff than you did before, okay? So when you think about an authentication bypass, it would be able, you would be able to get to any of this stuff without being authenticated. That's essentially what an authentication bypass is. Now let's go just, let's trigger some interesting, this is just a dummy account, right? But let's go over to the profile, and we're gonna look at my profile, and let's edit my bio, okay? This is just something fun to do. We're gonna say I'm the best, but not really. Okay, and hit save. So I have now edited my bio. That is an authenticated action. That requires you to have some sort of credentials, so that the website knows that I'm allowed to access and edit the profile page for user Thrifty, right? Now let's go over to Burp Suite and talk about some stuff. As always in Burp Suite, this is kind of the default config, right? You've got the unrequested items, everything's kind of all showed. I like to go show all, show only requested, show only in scope when I'm starting out, just to try to find just the request I'm interested in. And this is the request we're interested in right now. So this, and by the way, for those of you hackers out there watching this, none of these cookies will work after this video. So if you're trying to be clever and break into my dummy account, for some reason, all these cookies and tokens and things will have been invalidated by the time you see this. I love you, but that's just me. So the first thing you've got to do when you're trying to look for authentication bypasses is you need to understand the authentication mechanism that the target is using. How is this thing determining who I am? I have no idea, because I've never really looked at trying to hack Bugcrowd before, but let's go over and send this to the repeater, and I want to show you some stuff about sort of testing for auth bypasses. The absolute easiest type of auth bypass is when you figure out an endpoint that simply does not require the authentication cookie or token in order to return the data or do the thing. Okay, so the first thing we've got to do is send this request over and understand a baseline of what it's supposed to look like. All right, so as we can see, a correct request that works says 200 OK, and it responds with a set cookie crowd control session. Maybe that's the auth cookie and it renews or updates every time you do something. We're not sure yet. Let's send it again. Okay, so you can replay this payload over and over again. That tells me a couple things. The CSRF token that's in the header here is not one-time use. All right, so that's good. That's convenient for us, so we don't have to keep scraping the token and intercepting the payload every request, which is really annoying. Let's take that off and see if it's even required. Yeah, so you got a 404 without the CSRF token. That's fine. So we know that that's required in a payload for it to work. That's an important piece of information. Let's start dropping these cookies one by one or in groups. In my experience, these are probably not going to make any difference. So we're going to just get rid of these GA, what look like tracking cookies, the AGS anonymous ID. We can just delete that whole subset of cookies. And let's send it again. And it still worked. Let's drop all these that have an underscore HP2 on them. And let's send it. And it still worked. Let's drop all of these RTFL cookies. I'm not sure what they are. Who cares? Let's see if it works. Okay, we're still good. Let's drop the intercom. I'm pretty sure that's a chat session cookie. And this other AGS user ID, AJS. And hit send. And it's still working. And let's drop the CFBM that I accidentally looked right over and send it. All right, cool. As I suspected, all right, so the crowd control session token is the authentication cookie for this website, okay? It's not token per se, this gibberish, right? This gibberish cookie is what's telling the website that you're allowed to be doing the stuff that you're allowed to do. On the back end, it knows that this is user thrifty, and if it's doing role-based access security and checks and stuff correctly, it's going to say, well, he has the role and the access to edit this biography, but only his biography, not everybody's biography, right? Because that would be bad. That's called broken access control. We're not really looking for that right now, where I could sort of test other users or update other user stuff. So what happens now if I completely remove all the cookies? All right, we're going to take that off and send it. 404 not found. Normally, you would get a 401 or a 403 response code when there's an access violation of some kind. Bugcrowd has chosen to return a 404 instead, which is interesting and fun and cool, and I guess that's to make it harder to tell what it is you're looking at when you're scanning and whatnot. So this is our authentication cookie. Now that we know that, let's go over to our extender, and I'm going to turn off all these other things real quick just to kind of make sure my toolbar is not too cluttered. And what we want to do is turn on authorize. It's like authorize without an H because somebody probably forgot to put the H in there when they named it. That's got to be why it's called that. So let's turn on the authorize extension. And this extension is great because it will automate, you know what, my face is going to be really in the way. Ha! There. It will automate testing this for you. So what you can do to test every single request on bugcrowd.com as you use it is you can turn this thing on, and as you use the software and everything as usual, it will keep a log over here of whether or not it was able to bypass. And this is useful for privilege escalation or for just checking if authorization does or does not work. So what we're going to do is we're going to set it up a little bit. Right down here it says scope items only, content is not required. Okay, I like to add the scope items only down here because I don't want it intercepting and checking authentication on my stuff that's not in scope, okay? And you can add a whole bunch of filters to tell it what it is you want to check auth on and what it is you don't want to check on. And as you can see, it's pretty obvious if a URL does or doesn't contain something, if the request body does or doesn't contain something, methods, etc. You can filter the results if you're getting a bunch of trash or noise in there. Now we know that this is the cookie value we want. So what we're going to do is just copy the entire cookie header, all right, and we're going to come over to the authorize, and we're going to put there's a couple ways you can do this actually, but we're gonna put it in like this, and just put let's leave it like, well, what this lets you do, and we're not gonna do this. I just used a bunch of words for no reason. If you wanted to check another cookie, say this was a website that had 2 levels of permission and you wanted to check another cookie, you could like insert user B's cookie into this value, and it would check if user B is able to do something against user A, and you can look for IDORs and privilege escalation sometimes and things using that method. What we want to do is actually completely drop the cookies. Okay, so what you can do is just leave it blank, I believe. We'll see. Let's do a fetch cookies header. Does it let you do that? We have to actually get it on first. Turn authorize on. Let's resend this real quick and hit save. I want to show you what it does. All right, here we go. So patch profile users, it says it was bypassed, but it really wasn't bypassed because we didn't tell it what to do. Okay, it doesn't know what the authentication mechanism is for the website, just like we didn't know what the mechanism was for the website. So you need to tell it what it is you want to do to bypass the auth. So what we're going to do is type in cookie, right? Let's go over here and say cookie. Let's see if we can just do cookie. I've never actually tried that. I like to try new things while recording a live video, and just say hi equals yay or something. And what that should do is replace the cookie in the payload with the cookie hi equals yay, and see what that does. So let's go ahead and now re-request this and hit save. There we go. So what we've got, and I like to sort with the newest one up top because it's easier to see. You can see now that it's saying that it was enforced. So what it's doing is when I make that request, it tries the first request. Let's right click on this and look at it. It says send original request to repeater. So this is what the original request looked like with all these cookies, right? We saw that already. Now if I come into authorize and right click and say send the modified request to the repeater, where's my cookie? There it is. So as you can see, it took all the cookies out and replaced it with cookie hi equals yay. Because we know that that one cookie was required, this is basically giving it no cookies. I believe you could also just leave the header blank. I'm just curious since we're tinkering here. And let's do that again. You don't have to click save or anything. It's sort of magical. It's like a unicorn. It's like a magical unicorn. And yeah, that worked too, which is good. I was kind of wondering what that would do. So there you go. You could just give it a blank cookie header and that'll automatically replace the all the cookies with nothing. So now we can go over to our website and we can click things. Let's go to CrowdStream, la-di-da-di-da. Let's go to leaderboards and la-di-da-di-da. Let's go to payments. I've got tons of money in here, but not really. Let's go to submissions. Let's go to discovery. All right, we click buttons. Now let's go back over and look at our traffic again. See, and as we're using the software, it sort of checks things. Yellow orange is like, I'm kind of confused. Maybe the response was slightly different or something, but it's basically saying it's enforced. So as you can see, the response, the one thing you can look at is the response sizes are the same, right? If all these numbers match, it means changing the cookies didn't do anything different, right? I think that's probably true. I don't know why I said oh, I'm sorry, I was looking at that wrong. Rephrase that entirely. They should be different. The original request and the modified request should be different if the security is enforced. Okay, there, that makes more sense. Good gosh, computers are so hard. If you got the same from the original and the modified, I was looking at the wrong columns. If you got the same from the original and the modified, it would mean that, you know, it's bypassed essentially, right? Because you're getting authenticated data back. All right, so this is one type of authentication bypass. It's the most simple kind. It's when you figure out what the cookie is or what the authentication header is, and simply you find an API or a request of some kind that doesn't need it, and that is some sort of privileged function that does things that's normally meant for an authenticated user, an administrator, or something of the application. That's sort of the generic authentication bypass example, right? Sometimes you can have a like authorization bearer you can have one of these, right? And if you can get the request to work without this authorization bearer header, or, you know, basic XYZ equals looking, you know, header or something, then you're going to essentially find an auth bypass. Whether or not they pay you a P1 for it will determine on the impact of the auth bypass. Sometimes it's the entire suite of software or something really extreme, like being able to get to any user data and stuff like that. And other times it's just like this little tiny Tiny thing. Imagine your house, right? And the door is the way into your house. Well, somebody manages to break in through a window that wasn't properly secured, but they're locked into the room attached to that window. So you can't get to the whole house. You can't get to everything in the house. You can only get to the stuff in the bedroom or the room that window is attached to in the house. So you can get to a couple things. Still an off bypass, right? You're still bypassing security. It just depends on the impact of what it was you were able to find. I have not done much on fuzzing, so I'd like to talk about the concept of fuzzing here for a moment. Fuzzing, web fuzzing, also known as randomly sending entire words, strings, files, or things really quickly at an endpoint to find stuff that isn't listed. That's the really long version of fuzzing. Is useful for finding backdoors and hidden files and credentials and all sorts of things, and it can lead to authorization bypasses. So what you can do, if you wanted to, is you could like right click on a payload and send it to, well actually let's craft it as a GET request first, just for simple. So we're gonna just do regular bugcrowd.com right now, and we're gonna get rid of all these extra tokens we don't need, and let's hit send. Moved permanently to https bugcrowd.com/why though, why don't you like what I did? All right, let's just follow the redirection. Okay, so here we've got just a blank regular request to bugcrowd.com. Now let's send this to the intruder. Right click, send to intruder. Let's talk about fuzzing and how you can find off bypass things with fuzzing. Ginger ale. That's amazing. So to fuzz, for instance, a root directory. Say you want to find a bunch of directories and you didn't know if they were there or not. What I like to do is just type in test. And this is our burp intruder tool. You can highlight the word test right after the slash, okay, because we're looking for hidden folders or anything really that indicates something interesting may be there. This could be files too, it doesn't have to be folders. Files that may exist in the root directory of the path. So we're gonna hit add, add our little dollar signs that aren't dollar signs. Those probably have a name, but I refuse to go look it up. And that's all we gotta do now, okay? So we're gonna come over to payloads and we're gonna keep it set to simple list. And from the payloads, I would like to load, look at that, it's like I used a thing here recently. Let's just look for directories, okay? And this big directory list I use it's just got tons of crap in it. Some of it's trash, some of it's really useful, but it finds lots of interesting things, and the words and whatnot have been extracted. So it's got 172,000 different random words that tend to find interesting things. And I don't want to, this is Bugcrowd, right? So we're probably going to get throttled if I go too fast. I'm assuming they're not going to let me just spam them to death, but let's do 10 requests a second and see how far we get before it blocks me, just so you can get an idea of how a fuzzer works. And we'll hit start, okay? And let's see what it's doing here. Yeah, I got throttled immediately, in fact. Wow. Security, man. Most targets, I'm going to be honest, most targets will let you slam them as fast as you want to using a fuzzer. It takes some real security to stop your fuzzing attack after like 3 seconds. So that's good on Bugcrowd, right? So what we were seeing before we got throttled was that there was a redirect for each of these requests. So it didn't like the format I was requesting it in. It was doing a 301 redirect for everything. And so we would need to address that to get the fuzzer to actually tell us if something was there or not. But regardless, we got a 429 too many request header back because they're using Cloudflare. So this would not be a good target to fuzz on. I just wanted to give you an example of kind of what that might look like, right? So why don't we go to a different target for the fuzzing? I think it's important to see how that works. So if we come over to, I'll use my own cruddy website because I know pretty much nothing's there. Actually, that's pointless because I know nothing's there. Let's do twitter.com. We did twitter.com yesterday. I'm not condoning you to go fuzz twitter.com a bunch. They have a public bug bounty program. So, I think that they're probably going to block this pretty quick too, but let's just see what happens. I'm going to add twitter/.com. And let's go reload that page so we have something easy to send over to our intruder site. Twitter, get, right click, send to intruder, boom, we're there. Clear all the existing dollar signs, add the word test, highlight test, click dollar sign, hit payloads, go to load. Load directory list big. It takes about 5 seconds because it's massive. And we're going to go to resource pool. We're going to do a 10 simultaneous and start. And let's see if we do a little better than we did with bug crowd. Yeah, we're having more fun here. Okay, so as you can see, we're getting different responses for things that exist. So, yeah, now we got blocked. We got blocked a little slower on Twitter than we did on bug crowd. That's okay. Twitter's a little bit loosey-goosey with the fuzzer, but that's all right. And you got to note, if you still wanted to fuzz and they had this mitigation in place, you could just slow it down. There's usually a rate that's acceptable. It may be 5 per second, it may be 5 per minute. You've got to figure out what it is, but you know, you could run it overnight and potentially still get the results you want. It's just not as thrilling as running 100 threads per second and finishing in, you know, like a minute or two, which you know, I sometimes do on targets. But let's look at this real quick so you understand what's up. And the response codes when you're doing a fuzzer indicate that something interesting may have been found, as well as the length of the response. So let's sort on length here and come on down. This one's a little interesting. There we go. Privacy page, right? What it's saying is basically, yeah, something's here, but you didn't request the exact page where it lives, so I'm telling you where it does live, and I'm bouncing you over to that, right? So sometimes you can use a fuzzer to find a trigger page that then bounces you to another page that then is something meaningful. Same with the TOS, it's actually redirecting us to /en/TOS. The rules page itself, see it redirects to rules and policies, Twitter rules. Applications goes to settings/applications. That's kind of interesting, right? Because settings sounds like an authenticated function. So let's send this over to, I'll send this over to the repeater here. And yeah, where's the set? All right, so we're going to request this, and it's going to go ahead and redirect us. Let's do follow redirection. And we got settings, applications, and something went wrong. Try reloading. See, now that's interesting, right? We just fuzzed for a couple of seconds and we found a page that I think it expects you to be authenticated to view, and it blows up, and that's neat. Just a quick example of how you might can find pages with a, you know, by fuzzing. Similarly, you don't have to. Let's send this back over to the. Let's do the API this time because I'm not blocked on the API yet. It's probably a different target entirely. So let's send to intruder. Yeah. My brain's having a thing this morning. Clear. And let's not do a post. Let's take all this post crap out of here and turn it into a get again. And this time I want to look for files, right? So same thing. Let's do test. Let's do add. And let's do a load. And let's do like just random file names, okay? And this is a file names list. And let's go over to 10. Let's see how far we get before we're blocked. This one may not have. Oh, there it is. I have a block. No, I was gonna find all your files. We didn't find anything there interesting. It was all 404s before we got blocked, and then of course these symbols are killing the server, and it doesn't know what to do with it. Just an example of how you can look for stuff. Go out on GitHub and search for these files, right? Files to fuzz with. They're everywhere and for every type and architecture of software. If you know what the target is, you can look for them. These can lead to authentication bypasses. That's why we're talking about this. I didn't just bring up fuzzing for no reason. Oh my gosh. Okay, other ways you can get an authentication bypass. You can sometimes brute force. This requires talking about JSON Web Tokens a little bit, but sometimes you can brute force the encryption key or the signing key of the tokens. Okay, so let's go do a quick lesson in JSON Web Tokens. I think that'll be fun. JWT.io. Hi-ho, it's off to JWT we go. Okay, so depending on the algorithm of this type of token that's used, and let's look at RS256 just to make things. No, let's do HS256. I lied. Let's try to keep this simple. Sometimes you'll have an authorization bearer token, and let's talk about this because this is a new modern authentication method you're going to see a lot, and it's good when it's implemented correctly, and it's bad when it's implemented incorrectly, like most things. Authorization bearer. So this is what it would look like. You would see an authorization bearer header with an EY. It's almost, I don't think I've ever seen it not start with an EY. And that's your sort of indicator that you've probably got a JWT, and it's probably base 64 encoded. So you can either take this value, if you see this on the website, and come over to your decoder tab, paste it there, hit decode as base 64, and change it to text, and you can read the plain text portion of it, not the signature portion after the last dot. But you'll be able to read it just like you can pasting it into jwt.io. It's just base 64. Now, how does a authorization bearer token work? Well, that's a great question, people. I'm going to tell you. It works by sending over the information about you and who you are and what you're allowed to do on the website in plain text. So let's say, let's come down here and let's add a new, is it going to let me hit enter? Wow, that's hard. Yeah, like called roles, and let's just say admin or something like that, okay? So this could contain all sorts of different payload data about you. It could contain your user ID, your name. We'll say this is your user ID, okay? And so the subject is usually who the user is referring to anyway, but anything can be in the payload data. And you should never store sensitive information in JSON Web Token, because they are plain text still, kind of like basic authentication, right? What happens is this information right here in the first two groups of dots, you can see this is the header of the information. This tells what type of algorithm it's using, how it's encrypted, okay, how it's signed. This information is the payload body. This is the stuff that represents you and what you're allowed to do. So it's going to have your scopes and your permissions and your roles and your user ID and whatever it is they choose to put in there. And this last bit is the it's the HMAC. I don't want to get into what that is exactly. Let's call it a signature that verifies with a password that this information plus a secret password equals this signature. So what happens is, if an attacker gets this and tries to, say I try to modify this user ID, right, to a 1 or something, like I added a 1 to it. Well, what happens is, watch the signature value. See how the signature value changes when I do that? Let's highlight it. C5JJ, now it's SOVY it starts out with, right? Because this information is changing the signature. So what happens is, if that signature is not valid on the server side, being signed by the right password, like down here, or so let's say the password was secret squirrel. See how every time I change a letter right here, it changes the signature? That's because you have to know the secret password in order to change these and validate it. So why are we talking about this? Well, for an authorization bypass, sometimes you can guess this password. And if you're able to guess this crappy password or brute force it because somebody signed it using HS256 or something and used a password like password, right? Well, there's tools out there like Cookie Monster and some others that you can use to try to brute force this. And if you get this password, that means you've essentially created an authorization bypass, because you can now be any other user you want to be with any other roles you want to be, because you can change your user ID and your name and your roles, because now that you know this password, you can create your own tokens just like the server would. That is another type of authorization bypass. Sometimes also with JWTs, there's this idea of algorithm or header exclusion entirely. Sometimes the server fails to check if like this is set to none. Borks though over here when you do that. There's a tool in Burp Suite. Let's take this token that we've already got right here and let's pull up Joseph right here. It's called the Joseph Attacker. And I use this as a real quick check when I'm looking at JWTs. Paste your token into Joseph here and hit load, and then go to signature exclusion. We'll just talk about that one right now. And there is this concept of an algorithm none, right? Which means there actually is no signature. If the algorithm's set to none and the server will process algorithm none, you can change the token by dropping off the signature entirely. So if we change this to algorithm none and hit update, we now have a valid JWT with a header of algorithm none and no signature at the end. Let's go paste this back over here. And as you can see, alg none, type JWT, and there's no HMAX signature. So if you're able to pull that off and the server likes it, you've also found an auth bypass. So what am I saying? I'm saying that auth bypasses can occur not only by dropping the authentication token or header that's required, which is usually a server misconfiguration, right? Whoops, we just forgot to check for it. But you can also attack the cookie or the authorization method itself if you're able to figure out how it's generated and regenerate it yourself. So that's another potential avenue. There's actually a lot of ways to achieve auth bypasses. Again, like I said, finding hidden files can lead to an auth bypass. SQL injection, right, can lead to an auth bypass because you're able to mess with, the dialogue, potentially bypassing the need for a username or password if that's where the injection point is, or possibly withdraw everybody's passwords. But either way, SQL injection's a P1, so kind of a moot point there. I just wanted to point that out. Request smuggling, which is an advanced topic, a very confuzzling advanced topic that I'll make a video on eventually, can also lead to auth bypass because the front-end server or the back-end server sort of inherently trusts the front-end server, and if you're able to fool it into doing things that it's not expecting to do, it can sometimes send you back sensitive data, including cookies and authorization tokens and account information and all sorts of fun stuff. So this is a great overview, I think, for people starting on auth bypasses. In fact, an IDOR semantics a little bit here really can be an auth bypass itself, depending on where it exists, right? You can still have an authorization token that's required to be present, but maybe by changing an ID value somewhere, you have achieved an auth bypass. And maybe also a header. Maybe sometimes there's a hidden header like xadmin equals true, or xip is 127.0.0.1. Maybe you can fool it into thinking that x forwarded for, there's all these little headers out there that are custom, and sometimes you can trick the server into thinking you're local host or you're an admin or something just by doing header injection, which will achieve an auth bypass. So again, the auth bypass is a unique little baby, and there's a bunch of different ways to achieve it depending on the target and how it's implemented. But I wanted to give you an overview because I think this is a good start. I think you should probably run authorize whenever you're testing new targets, especially like if you get a bug bounty invite to a brand new target or something. Definitely have this on while you're crawling the website, because it can definitely find things for you where they forgot to require a cookie or an auth header. And again, if you're trying to do privilege escalation, paste the other cookie in here too, and what it'll do is it'll check that one right here, and it'll check the other one right here. So you can do two things at once. You can check to see if one user can get to another user's data using their cookie, and you can also check if it works with no cookie. So it's a really great tool for checking broken access control and broken authentication all at once, and very customizable. Listen guys, I try to keep these videos to around 30 minutes. There's so much more I could say, but I've also got a lot more time in my life, hopefully, to create more videos for you. So thanks for tuning in. Please subscribe to get new updates and new videos, and do message me or reply to these tweets on Twitter if there's a particular topic you want me to go over, or more detail you want on something, and we'll get deeper and more advanced over time as we go. Thanks again, everybody, and we'll look forward to the next one.